questo seminario. Shireen Assaf. Shireen sta concludendo il suo dottorato proprio fra pochi giorni, le discussioni dell'11 aprile, 11 aprile ed ha utilizzato i dati passi per la sua tesi. Vi spiego velocemente il problema. Il seminario, come vi avevo anticipato, sarà in inglese, ma vi faccio una piccola introduzione, magari per chi però ha qualche maggior problema con l'inglese, e del motivo, soprattutto dell'obiettivo che siamo posti con in realtà tutto il lavoro di tesi di Shireen, perché siamo partiti a tabula rasa dicendo: va bene, io ho questo problema, io voglio poter modellare non solo i trend ma i cambiamenti che ci sono stati dentro possibili sottogruppi, cioè modellare la relazione che c'è fra, adesso lo spiegherà meglio lei, la relazione che c'è fra le variabili come varia nel tempo. Ad esempio sappiamo che c'è una relazione fra determinati sociali, fra il reddito e una qualsiasi altra variabile, ma questa è stabile nel tempo o il fatto di essere a basso reddito ti peggiora la probabilità di essere fumatore, ti migliora, eccetera. Tutto questo in logica ovviamente di una modellistica che tiene conto di tutti gli altri, controllando per tutti gli altri possibili effetti. Potevamo applicare diversi modelli. Il primo anno di Shireen è stato praticamente perso, fra virgolette, a giocare con i dati e a studiarsi una serie di modelli. Alla fine siamo concentrati su questa categoria di modelli per motivi che adesso vedremo, vi spiegherà, e oltretutto il risultato credo sarà fortemente di interesse, perché vedrete che hanno diversi vantaggi dal punto di vista metodologico, e ve li spiega lei. Invece potrete apprezzare come la lettura del risultato invece è una lettura abbastanza semplice, perché sono odds ratio che conosciamo, semplicemente la traccia dell'odds ratio che varia nel tempo. Allora direi una mezz'oretta, ok, half an hour, per il seminario, dopodiché domande. Sulle domande, se ci sono domande tecniche eccetera eccetera, sul come è fatta la procedura in R e quant'altro, risponde chiaramente Shireen. Invece le domande più sostanziali, come potete fare tranquillamente in italiano, ve le faccio carico io.
Grazie. Thank you for your invitation and for the opportunity to discuss my research with you. I'm sorry I cannot present in Italian. Unfortunately, my Italian is basic. My research was to analyze BRFSS data, such as the PASI, for spatial and temporal trends using varying coefficient models, which I will explain shortly. So I will introduce this type of model, and then I will concentrate more about how I apply this to the PASI data using a smoking status outcome variable for a time-varying coefficient model. And then I will show also very briefly how this can also be used to study spatial variation. But this was using US BRFSS data. So the problem, the motivation of this work came from the need of advanced methods to study trends in BRFSS data, such as the PASI, since usually trends are studied by observing the prevalence or the means across the years and perhaps across various categories, and so the measures are usually aggregated, and a more in-depth analysis to assess whether the coefficients themselves are changing, not just the outcome, is not usually performed. So the coefficients are usually assumed to be constant. In addition, we wanted to find a method that did not require aggregation of data, which can be seen as an advantage, so you have less loss of information. So the proposed method was a varying coefficient model, which was not performed on this type of data before, but it's well established in the literature. And it uses non-parametric techniques and can be be very useful in capturing the dynamics of this type of data, since it allows coefficients to vary with time or space using smooth functions. It does not require aggregation of data, which is another advantage. And also it produces results that are easily understandable, because you can produce odds ratio plots. So it's very clear. That's for the time varying coefficient model. For the space, you have something that you can produce like probability maps, which I'll show you in this presentation. So for the PASI, here I'm presenting the analysis I've done from 2008 to 2012 for smoking status outcome variable. Also, I will show what I've done with the US Bureau of SS for obesity outcome for spatial varying coefficient model. So very briefly, to understand what is a varying coefficient model, I'm showing you first the standard linear model. So here, as we know, the coefficient A is constant. In the standard varying coefficient model, we have another covariate U, which is referred to as the effect modifier. And here, instead of the coefficient A being constant, it's a function. It's A of U. So here we're estimating the functional coefficients A of U. This is the aim. And then the generalized varying coefficient model just involves a limb function, and this is especially important since I'm using binary outcome variables. The estimation in the literature was mainly concentrated in non-parametric techniques, and it uses either spline estimation or kernel local regression. And splines are just piecewise polynomials that are joined at specific points, position points or nodes. And various splines depend on the basis defined as well as the order of the spline and the knot placement. And I'll show very briefly this in the next slide. And I used spline methods because it gives more control over the smoothing than local regression methods. So I'm not going to speak very much about estimation because the concentration here was about the application, but just to briefly understand, if we have a model as shown above, then to find the estimates, we minimize the following. So we have the usual sum of square residuals plus a penalty term, P. And to do the computation, we take the functional coefficients, the A of U, and we express them in terms of splines, which are these types of functions. So we have here A of U, and here there's an NJ, which are the knots, and these are the unique values of our effect modifier, for example, time. And the B are the type of spline or type of function chosen. In the analysis of the PASI data, P-spline estimation was used. So now to the application. I used, for the PASI data, I used the period between 2008 and 2012. There was a smoking status outcome variable, which combined, for smoker, it combined quitter and smokers. And for non-smoker, it combined non-smokers and ex-smokers. And then I had independent variables, mostly to represent social demographic variables, but also alcohol consumption, physical activity, and depression status. The sample size was around 185,000 observations. So how I constructed this model, there's two main steps. The first step is to see if each independent variable I have has coefficients that are actually varying. So you have to test if it's varying or should I keep it constant. So here I have the null hypothesis, which is our usual logistic parametric model. I have the logit of smoke, and Z are just all my independent variables with constant coefficients B. And in the alternative hypothesis, I'm seeing if one of my independent variables, x1 in this case, has varying coefficients A1 of t. So basically, I perform a chi-square test, and I see if I need this last term, A1 of t x times x1, if it should be in the model or not. I do this for each of the independent variables. And then in the second step, those that were found significant in the first step now should be combined together. So in the second step, I see if I can add another variable with varying coefficients if one is already present in the model. And then I continue in this way in a stepwise fashion until the final model is reached. So how this is done in R, I used the MGCD package, which is designed for generalized additive models with non-parametric techniques. The function I used is the BAM function because instead of the GAM function, because it's designed for large data sets. So I found through my research that this took minutes instead of hours and days sometimes even. So here is the sample code. We have our outcome variable, the function BAM, our outcome variable. I put Z to represent all the independent variables. Then I want to see if income is time varying or not. So I have S is the function to represent using spline methods. I have time, which is my effect modifier. I have here these are the other details to define the spline. So DS is to say which kind of spline you want to use. Here I have PS, which is P-spline. I have 55 knots, K is for the knots, and this is because there's 55 months, so it's the number of unique values of your effect modifier, which in this case was time. So 55 months, and then the M is the kind of penalty that you've seen before. So this is, for example, was recommended from the literature that for P-splines you should use a third-degree spline with a second-order penalty. So this is the basic code that I've used for all the analysis, and this code here fits the following model, which is a time-varying coefficient model where income has time-varying coefficients. So following all the steps, step 1 and 2, this is the results, just to show you how it's proceeded. So the top part of the table is showing you the step 1, where I looked at each variable by itself to see if it has time-varying coefficients. LM just means the logistic model, the parametric model. So I'm testing each one against the parametric model as I showed you in step 1, and they were all significant. But then when I go to build the model in the second part of the table, the bottom part, after adding age and alcohol and physical activity, all the other variables gave me insignificant p-values, so they were rejected to have time-varying coefficients. So what does this mean? This is the final model I reached, which has, again, we have the Z are the covariates with constant coefficients D. But age, alcohol, and physical activity were found to have time-varying coefficients. And we also have a time-varying intercept here. So all the other variables were found to be actually constant, have constant coefficients for that time period. So how to represent the results? We can look at a table like this where you can look at the odds ratios of the constant coefficients and p-values. You can also see the p-values of the splines. But a better way to represent the results is the odds ratio plots. And here, for example, we see that for the age variable, that for the age category 40 to 49, we have a decreasing odds ratio that's below 1. So this category, this age category, they're less and less, have less odds of being smokers compared to the reference category of 18 to 29. And this is decreasing with time. The other age categories were actually more or less constant in this case. These are the odds ratio plots for...
excuse me, perhaps I can comment on this because this is the main result. As you can clearly see, also from a policy point of view, we have been effective with age 49, but we have not been effective with the other age categories. And this is very interesting because we know that those were already quite well off because, as you can see, the red line is odds ratio equal 1, so they were lower than the other categories, so and they're getting better. But for instance, the other groups are not moving at all. And particularly it's not moving the reference categories, that is the younger people.
Yes, this was the question, is that the reference is always age 18-29 and they are not affected by the time, are constant over time?
Well, in the odds ratio plot, of course, I cannot produce it for the reference.
Of
But,
course.
yes, they were not...
Was the prevalence pretty stable? In
Yes,
this
but
category,
it was stable,
at
yes.
least, so
Yes.
that we can...
Of course, if you want to plot...
No, because of course if we are thinking that this is a way of interpreting the efforts in preventing, we should have a decreasing proportion always in the age, also in the age 18 and 29. And the fact that this is significant is that maybe the decrease is even higher in 40-49.
Yes,
So
and
we should not underscore the
for that
effect.
policy purposes, perhaps it would have been better to have taken another reference, Asian reference
Yes,
group,
yes.
to show how it's
No,
stable.
because the interpretation is not that we have not been effective, but because maybe we have been effective, but not not more than in the reference age 18
Yes,
and 29.
yes.
This is the comment.
Yeah, okay.
For the alcohol variable, we see that those who do not drink also are decreasing their odds ratios, and this is below 1 as well. But for the lowest drinker, it's more or less stable. And finally, for the physical activity variable, even though it was required in the model, the categories are more or less also constant.
Excuse me, who is the reference in the alcohol?
High-risk drinker.
High risk, so it is not drinking compared to the low drink.
Yeah.
Is the comparison?
Yes, the reference is high.
Okay, yes, that's true.
So that's the results of the PASI analysis. I wanted to also show briefly how this can be used for a spatial variant coefficient model. So here I applied US BRFSS data from the CDC for one state, Florida State, for 1 year, 2010. And here the effect modifier is space instead of time. And the same methodology can be used, except now I have a tensor product or a product of two smooth functions because I have x and y coordinates. And I'll explain this shortly. So the method, again, for Florida for 2010, and I used the centroids of the 67 counties of Florida State. And so what is required is that I match these centroids to the observations, since in the questionnaire they ask them which county are you from, so you can match it. The outcome of interest here was obesity, also a binary outcome variable. Independent variables, again, mostly social demographic, but also physical exercise, smoking status, having a health plan or not, and general health status. And the sample size was 32,000. So similar to the code I've shown you before, here we have the obesity outcome. Here I'm testing if income is spatially varying. So I have TE, which represents tensor products of splines. And I have here XY, the X and Y coordinates. And here the knots are 10. And when I supply one number here, it means I give it to each variable. So actually it's 10 for X and 10 for Y, so that's 100 knots, which should cover very effectively the 67 points. So the above code here fits the following model, similar to the time variant coefficients model. Here, however, we produce probability maps to represent the results. So probability maps are produced for each category that was found to be spatially varying. So, but before this, a reference plot is produced which shows the probability of obesity at all the reference levels. So there can be a comparison. So, and that's the map here. But then I selected some of the results to show you here. So here we have the probability maps for certain categories. As you can see, they're darker, so there are higher probabilities than the reference map. So that's one thing you can see. But also, if you look at each map separately, you see that there's some spatial variation since we have different probabilities in different counties. So that was the main result there. So the method proposed is able to show spatial and temporal trends to BRFS data and to highlight which subgroups have deteriorating or improving effect with time or space. The results of this first application for the PASI may change perhaps with more years of observation, since perhaps 5 years may not be long enough to observe a change in behavior in smoking at least. The method can be applied to any outcome of interest, really, but I recommend using a limited number of independent variables, because the more you place, it becomes very complex and very time consuming. With increased observation time, you have to increase the number of knots since there's more months, and this greatly increases computation time. And so, for example, when I applied this to the US BRFSS data for 14 years, I cannot put knots for all the months of 14 years, it's too many. I think I would still be running the code till now, perhaps. So what I've done is I selected 3 knots for each year, for a total of 42 knots, and then you can check if this is sufficient enough or not. So for the spatial model, perhaps the same can be done with the PASI data using the local health units, perhaps taking the centroids or the population centroids, and to create a spatial model also with the PASI data. And also perhaps the next step could be to combine a spatial temporal model. And this would basically in the code be X, Y, and T. And this would be using tensor product smooths as well. So you can see how it's changing with time and where the change is faster or slower than other places. And this is it. These are some of the main references. And thank you.
Questions or domande?
No technical questions, I think, because it is very complicated. With the formal algorithm, I am not at that level, but definitely this is a very... It looks like something which could be used also because you are using an application of the package, statistical package R, which is available, I suppose. Do we use it? Do we have this... Okay, so we can have all this one. And I think that it will be very, very exciting trying to apply, hopefully understanding what we look at.
Se posso aggiungere sull'analisi spaziale, il metodo del centroide può essere applicato, guardo Giuliano perché so che lui è molto sensibile a questo, non necessariamente al discorso del comune, perché in alcuni casi i comuni non ci dicono niente, però tu puoi applicarlo tranquillamente, per esempio per fare un confronto città, aree rurali o per livelli altimetrici dei comuni.
Certo, e noi allora già, poi magari produci, noi
lei ha una comprensione.
Posso fare solo una domanda teorica? C'è un limite inferiore della quantità di dati? Do we have a lower limit of the amount of data we should use for applying these? Because I understand that especially the BAM function is also for the large data set. So if we pull together all the data from our PASI, we have enough. But if we start to disentangle the regional data, the municipality, the year, and then we wanted to have different things, the same, I mean, still the same statistical approach is working because it is not parametrical. So it is also with a lower number. That is very good.
You answer first and I will follow.
You mean lower sample size?
Yeah.
Yeah.
For the spatial and temporal?
Yeah, spatial or temporal for all these, for this identification of variable coefficients. Do we have sort of at least how many observations?
Well, I used it for 32,000 for Florida, so but
So it is above 1,000, definitely.
I mean,
I wonder if we have
Yes,
we need to have some caution when we want to apply in specific local situation.
Forse lei è stata, you have been very fast in explaining the method, la cosa che è profondamente diversa riguardo a quelli che hanno fatto il corso sulle serie storiche è che lì tu aggreghi per ogni mese, no? E dunque ti perdi un po' di informazioni. Invece qui tu prendi tutti i dati, cioè non devi fare un'aggregazione mensile, perché ogni dato si porta dietro il suo giorno, il suo località, eccetera. E questa è la forza. Dunque la sensazione è che funzioni anche per piccoli campioni e dunque che ti consenta per esempio di fare un'analisi di trend anche a livello. Ovviamente noi abbiamo usato i dati nazionali, però appunto i dati della Florida potrebbero essere i dati della Liguria più o meno come numerosità
Beh, su tutto il dataset del tempo, certo, se vai cercando il tempo, se invece vuoi
se
focalizzare
invece
su
vuoi
un'altra
cercare lo
variabile,
spazio è chiaro, tu devi prendere per esempio what was the sample size in Florida?
32.000.
but we have to have at least a minimum of 500 observations. In
Ok.
each county.
Ok.
Ok,
Each
ok,
county.
ok. 500
Yeah.
osservazioni per
500.
ogni campo. Ok.
Yeah. And that's why that's why this specific year was chosen, because they oversampled that year.
Sì, per
So
cui
I-
per ASL, voglio dire 2 anni di ASL va bene, per noi si
Okay,
potrebbe
because our-
fare diverse applicazioni.
As you know, our sample unit is the local health unit, and they do collect 250 roughly a year, so 250. So basically every 2 years they could run a mass like this.
Sulle analisi spaziali, allora sicuramente quella che dici te noi la facciamo da sempre, che stratifichiamo sia passi d'argento per montagna, capoluoghi di USDA, quindi le grosse città, un po' di più, il resto. Poi il modulo dell'ambiente, almeno per l'Emilia Romagna, abbiamo anche stratificato, oltre per questa cosa, per la classificazione Istat della bassa, media, alta urbanizzazione e anche per ampiezza demografica, 2.000 abitanti, cioè 0-2000, 2.000, 5.000, 5.000, 15.000 e via dicendo. Queste tre classificazioni più o meno si equivalgono, nel senso che almeno nella mia regione c'è proprio una quasi sovrapposizione tra urbanizzazione, essere capoluogo ed essere in pianura ed essere grande. Però questo è ancora a livello molto molto macro, cioè grossolano, che non dice niente. Io credo che analisi spaziali per comuni o aggregati di comuni che tu puoi aggregarli sulla base di qualche tecnica, e grosso modo ci sono due, e guardo Carla, gli estimatori bayesiani o l'indicatore kernel. Un tentativo con i dati passi l'ha già fatto con Vienna nella Puglia, poi dopo è uscito da passi e probabilmente non sarà più interessato. Nel mio servizio chi si occupa di mortalità fa le mappe con gli estimatori bayesiani di mortalità e su alcune cause di morte hanno delle numerosità che non sono diverse dalle nostre interviste. Quindi se loro hanno delle mappe che si vede benissimo che ci sono dei trend geografici, perché gli dico io non farne per i comportamenti che sono associati a quello? Se abbiamo il tumore di polmone che ha un trend geografico dove vede che c'è un cuneo che parte grosso modo dalla mia zona del terremoto, Pirandola, e arriva a Ferrara e a nord a Rovigo, beh, io una mappa del fumo o dell'ex fumatore ce la farei, perché ho già indicazioni molto spadometriche che se vai a vedere il fumo adesso è uguale al resto, ma la percentuale di ex fumatori è molto alta. Allora, queste sono informazioni che probabilmente mappate anche solo puramente a livello descrittivo, senza fare tante cose, danno già un contenuto informativo forte. E quindi probabilmente una ricerca, o anzi non più una ricerca, un'applicazione di metodi bayesiani o kernel sui dati passi, si può già fare oggi.
Certo, la cosa può essere seriale, nel senso che tu puoi prima andare a vedere attraverso quegli approcci quali sono le tue aree omogenee e poi vedere come variano le tue variabili su quelle aree omogenee. Non solo, c'è un terzo step che noi non abbiamo ancora provato, nel senso che molto un paio d'anni arrivare fino a questo punto, che è quello di mettere assieme l'elemento spaziale con l'elemento temporale. Something which is doable, but we have not yet tried. Perché con lo stesso approccio tu potresti aggiungere, avete capito, cioè il modello sembra complicato, ma in realtà non è complicato. Tu hai una parte che è una regressione sostanzialmente a effetti fissi e una parte che invece fai variare i coefficienti del tempo. Tu potresti aggiungere un'ulteriore parte in cui fai variare i coefficienti anche nello spazio, dunque è una variazione spazio-temporale. Quello potrebbe essere in alcuni casi molto interessante, nel senso che se tu hai visto che varia nel tempo e hai visto che varia nello spazio, a quel punto ti viene la voglia di dire ma com'è che si è modificato negli anni, soprattutto chiaramente se è uno span temporale abbastanza lungo, dunque per passi forse è ancora un po' presto, però certamente è una cosa che si può fare nel futuro.
Just one question to check if I got it right. How to interpret the results on the smoking status and alcohol. So, would it be correct to say that since we see that the smoking status is decreasing over time, right, in the non-drinker population, that it's easier to quit smoking for the non-drinkers as compared to the high-risk drinkers, right?
Yeah.
Is that correct?
That's
Okay.
also being a smoker.
And yeah, and second question in regard to the smoking and over time, in the age groups. So is it in this case? Couldn't it be that you see the decrease in the 49 age group, and then there is the stable situation, right? Do you have to take account for the right interpretation also the absolute prevalence of smoking status? What I want to say is, couldn't it be that the smoking status is decreasing because people are quitting smoking over time when they get older, but there's a hardcore of smokers that won't give up their habit. So it's not only the effectiveness.
The point is that here in some way you are catching the speed of the quitting smoking.
Okay.
So you're saying that speed is changing over time. So they are faster in the 2013. They are faster than they used to be in 2008. That's the reading, because
Okay.
you are estimating the change of your odor ratio over time. So it's not the odor
Okay,
ratio,
no, I got it.
but it is a change of your odor ratio over time. So basically, the starting point, it's difficult to read the scale actually, but it's a point 9. So you already have proved by your data that you got a relationship between that age category and quit smoking or no smoking behavior. Okay.
Okay. No,
But what the graph is showing is that this is changing over time,
yes.
and
I
so
understand.
in some way it's getting even better.
Yeah. Okay. No.
That's why I interpreted as
I see it
effectiveness
now. I didn't see it before.
of your program, if you have any program.
And eventually, I find very interesting the last thing you said, that you could apply this method to the spatial combined to time.
Mm-hmm.
So we could identify the local health units where things are moving and others where they are stable and so on. And now it's 500 observations per year you have to have for the local health unit. Is average, on average?
Yes, there is not a rule. That has been considered together with the CDC when she was, because she worked at CDC for 2 months, and when she were there, they wanted to try also to apply the spatial, and they decided it was meaningful to have at least 500 observations. But this does not mean that with less it's not doable. Perhaps it's more difficult to see some significant change.
Or you can put together some of the local
It's,
health units in bigger clusters and then...
Sure, that's exactly...
It's really, I think, very, very interesting.
Other questions?
You reduced the number of knots, of temporal knots. Which was the criterion to have this reducing of
For the
the
US
number?
data.
So is there a limit or?
You have to check the effective degrees of freedom. It has to be checked if it's sufficient, because you have to always supply a sufficient number of knots. If you supply too few knots, then you're not fitting you have an incorrect fitting of the function. So it's just a matter of checking. The more the better, but the computation time will be too much if you put too many.
This is part of the non-parametric technique, and of course it's always an approximation, and you have to balance the feasibility in terms of number of hours. We are talking about hours and days. Actually, something that Shireen had not time to tell you is that some other different way of estimation that we have tried, she has tried actually, we just abandoned because after a few days of computational time, say, well, it's not working.
Because another method would be, the ideal would be to check a criterion like the AIC for each number of knots, from the minimum to the maximum, to see what is the best knots. But this is what took days and days, so it's not feasible.
The computational time of the model that you have run with the PASI data, what was it? Do you remember, more or less?
With the p-spline method, it's like, oh yeah, I have it here actually, I'm sorry. It's a half hour because it's with a BAM function. Here are the times. Here are the times.
Oh, okay.
So but if you use the GAM function, it's many hours, maybe over 20 hours. So this is with the p-spline method and the BAM function, and it takes, the most complex model is about half hour. But the more terms you add, here I only have 3 time-varying coefficients, but the more time-varying coefficients you have in the model, which can happen if you are increasing your observation time, the more time it will take. Like the US data took about, I think it was 20 hours or something to finish the model.
Okay. Any other questions? Thank you, Shireen, very much.